Good morning. Clyde, can you say hello?
Hello.
Hello. And we're going to talk today about the earth. It's what's on the inside that counts. We're going to talk about the earth's interior a little bit. Right? So what we have here, right, is a little picture. And you can see there it's really, really hot. So we're going to talk about the layers of the earth and heat and then mantle convection. All right, Clyde, let's take a look at this, okay? So I like to compare the earth and the inside to that of an avocado. So we're going to take a look at that real quick. All right, so we're going to take an avocado, right? And this would be like the outside of the earth, like where we live, what we consider the crust. All right, and then if we could cut the earth open like this, all right, what would we see on the inside? All right, it'd be similar to that of an avocado. All right, Clyde, can you tell them what's the outside part called?
I will set it down.
Set it down. Well, I want them to be able to see, so you have to be able to see here. Outside is the crust.
Here's the core, and the smoothy part is core and metal.
Yeah, exactly.
That looks like Saturn.
It does look like Saturn. Yep, so we said the crust and the mushy green part. It's mushy. What is it?
Crust.
The mushy part is the mantle. And what's that inside part? The core.
And what's it? The smoothy part. It's
the mantle. All right, the smushy green part. Don't cut the earth. Okay, so what we have is the earth is divided into layers. So what we have is on the outside, right, just like the avocado peel here, we have the crust. And this is where we live. And it's very thin, relatively thin compared to that of the rest of the planet. Now, Earth's crust is not this continuous. It's like broken into pieces. So if we were to rip this into tiny puzzle pieces and put them together, that would be more accurate, right? And then if we were to go down, then we would get to the green mushy part, and we call it the mantle, this green mushy part here. It's not exactly solid, but it's not a liquid. It's mushy. And so the point is that the mantle moves. It's mobile, all right? It's able to move. And you can see kind of here, Clyde squishing up, right, some of that green mantle part. And then we get to the inside. You see here you have a large seed right there. And then it's kind of like the core. And the earth has a core too, except it's a little different, right? We have two parts of a core. We have an outer core that's actually liquid and then metal, and then an inner core that is solid iron and nickel. All right, so those are the different layers of the earth. So how do we get information about these layers? Well, actually, earthquakes, interestingly enough. So the vibrations from earthquakes kind of go all over, and they go through these different layers, and how they move when they hit different substances and different layers tells us a lot about if it's a solid, liquid, or gas, and the types of material it's made out of based on the speeds in which they move. So you can see here we have some bending. So it's almost like when you hit a different layer, right? You can get, just like when I put this pen, I don't know if you can see it, put it up here, a pen or a pencil in water, it appears to bend when the light travels through the different, through the air and through the liquid water, because the light moves at different speeds. So kind of similarly, what we get is the bending as it moves through different material, and it gives us, after we look at lots of different earthquakes, it gives us pictures, almost like these kinds of pictures. All right, so these are the sonograms, the ultrasounds of my babies. All right, this one's Clyde right here. All right. And it looks pretty much very much like him. Maybe not exactly, but it gives us a very good idea of what's going on inside. So the same thing with how we figure out about what's inside the earth. We use these waves, these vibrations from earthquakes, and then we can get a pretty good picture of what's inside. So even though we've never been inside, and we've actually never even been down to the mantle, we've hardly got through the crust, right, we can actually get a lot of information about what it looks like inside. All right.
It's kind of messy.
Yeah, the mushy part. What's the mushy part? The mantle. There we go. All right. What we've also found out about the inside of the Earth is that it's very, very hot. So that core, all right, releases a lot of heat because of radioactive decay, radioactive materials left over from the creation of the Earth when it formed 4.6 billion years ago. Right. So you can actually see here, it says the inner core is really hot at about 4,300 degrees Celsius. So we actually, the core is about the same as same temperature as the surface of the sun. So it's super, super duper hot. And as we move away from the core, it gets cooler and cooler and cooler till it gets as cool as the crust, like where we live. So you're probably familiar with those temperatures. All right. So again, as we go to the crust, to the core, it gets hotter. So what that leaves us with there, right, is uneven heating. We have a really, really hot core, and then we have the mantle, that mushy green part of the avocado, all right, that can move, and then a cooler outside. So we have uneven heating, in which we've been studying. Uneven heating leads to changes in density, because when something's more hot, it moves faster, becomes spread out and less dense. And when things are cooler, right, they become more dense, and they begin to sink, which leads us to convection. So based on your understanding of convection, I want you to predict the movement of that material in the mantle. So imagine that material is like this, the green mushy stuff of the avocado, and that the core, right, is super duper hot, and that's your heat source in the middle. All right, and I want you to use arrows, drawings, and that to predict the movement that you feel would happen inside the mantle here, caused by the heat of the core of the Earth.